Perseverance rover captured this view of Deimos, the smaller of Mars' two moons, shining in the sky like a bright star just before sunrise. Deimos is the smaller and outer of the two natural satellites of Mars, the other being Phobos. It has a mean radius of 6.2 kilometers and takes 30.3 hours to orbit Mars. The Moon is 23,460 kilometers from Mars, much farther than Phobos. Due to low light and long exposures adding digital noise, the image here appears hazy. Many of the white specks seen in the sky are likely noise. Some may be cosmic rays, and two of the brighter white specks are Regulus and Algeba, stars that are part of the constellation Leo. This footage was captured by NASA's Psyche spacecraft between May 2nd and May 31st in 2026, during the spacecraft's close approach, and departure while the mission performed a Mars gravity assist. The footage begins with Mars as a small crescent in the distance. During close approach on May 15, the red planet's cratered surface fills the imager instrument's field of view. As the spacecraft departs Mars, the changing perspective reveals the planet's icy south pole. Launched in October 2023, NASA's Psyche spacecraft is on a journey of more than 2 billion miles, 3.6 billion kilometers, to explore the metal-rich asteroid Psyche. The mission is expected to arrive in 2029 to study what scientists believe is the exposed metal-rich core of an ancient planet. The Mars flyby provided the gravity assist needed to continue that journey. Beyond creating this footage of observations of Mars with the spacecraft's multispectral imager, engineers can now hone the precise imaging and navigation techniques required to orbit the asteroid Psyche. Yardongs are common in some regions on Mars, especially in the Medusi-Fossi formation. This formation is found in the Amazonas quadrangle and near the equator of Mars. The Yardong unit seen here to the right of this observation is located at the foothills of Mount Sharp. Yardongs are formed by the action of wind on sand-sized particles, hence they often point in the prevailing direction that the winds were blowing when they were formed. They are parts of rock that have been sand blasted into long, skinny ridges by bouncing sand particles blowing in the wind, and layers are seen in parts of the formation. They also exhibit very few impact craters, indicating that the surface exposed is relatively young and the process of erosion may be active. The Medusi Fossi Formation, which features thousands of wind-sculpted ridges and mesas, has easily eroded deposits, which means that it is probably composed of weakly cemented particles and was most likely formed by the deposition of wind-blown dust or volcanic ash. A resistant caprock on the top of Yardongs has been observed in Viking, Mars Global Surveyor, and high-rise photos. Images from spacecraft show that they have different degrees of hardness, probably because of significant variations in the physical properties, composition, particle size, and/or cementation. Mars has a huge network of canyons that stretches about 4,000 kilometers across its equator. This canyon system, called Valles Marineris, is the largest in the solar system, dwarfing Earth's largest canyon, which covers 750 kilometers under Greenland's ice sheet. Valles Marineris has been captured by the HiRISE camera on NASA's Mars Reconnaissance Orbiter many times in its 19 years in orbit. However, this geological wonder still holds many secrets. Just recently, HiRISE captured some images of the eastern side of Cantor Chasma, one of the largest canyons within Valles Marineris, and what the images revealed could change how planetary geologists think about Mars' ancient environment. Using its ability to see detail down to the size of a kitchen table, HiRISE produced an image that shows layered deposits of sediment several meters thick. Crucially, these layers of sediment must date to after the canyon itself formed, because they appear to have been eroded, warped, and bent by tectonic movements. Mars doesn't have plate tectonics like Earth does. Instead, its crust is like one giant plate, but faults and fractures still form in the Martian crust as it cools. Unlike Earth's Grand Canyon, which was carved by a river, Valles Marineris, including Cantor Chasma, is thought to have formed by volcanic activity, with landslides, floods, and erosion later sculpting it into its present form. In 2021, water was found beneath the surface in Cantor Chasma. It's thought that up to 40% of the near-surface material in Valles Marineris could be water. That would make it akin to Earth's permafrost regions in Alaska, Canada, Greenland, and Siberia, where water ice permanently persists under dry soil because of the constant low temperatures. This impact crater is located on Vastitas Borealis, a broad plain that covers much of Mars's far northern latitudes. The crater is 35 kilometers wide and has a maximum depth of approximately 2 kilometers beneath the crater rim. The circular patch of bright material located at the center of the crater is residual water ice. This patch of ice is present all year round, as the temperature and pressure conditions do not favor the sublimation of water ice. The ice cannot be frozen carbon dioxide, since carbon dioxide ice had already disappeared from the North Polar Cap at the time the image was taken, during late summer in the Martian northern hemisphere. The height difference between the crater floor and the surface of this bright material is 200 meters, which cannot be attributed solely to water ice. It is probably mostly due to a large dune field lying beneath this ice layer. Indeed, some of these dunes are exposed at the easternmost edge of the ice. Faint traces of water ice are also visible along the rim of the crater and on the crater walls. The absence of ice along the northwest rim and walls may occur because this area receives more sunlight due to the sun's orientation.